Good morning, students. In last class, we studied polar representation of a complex number. Okay, in polar representation of a complex number, we have to find modulus of a given complex number, and also we have to find argument of a complex number. Argument is also called as amplitude of a complex number. That means we have to find the value of theta, right? The value of theta. What is our polar representation? Polar representation of a complex number z is equal to, what is that form? R into cos theta plus I sin theta. In this polar representation, what we have to find? We have to find the value of R and also the value of theta. And here we have to remember one thing, right? Theta value. Here we are defining that theta is a principal value, right? What it means? Principal value means what? That theta lies in between. Theta lies in between minus pi to plus pi. Then only we can say theta value satisfies our argument of theta. After finding the value of theta, next we have to check, is it theta is in between minus pi to pi or not, right? If it is not there, means we have to convert it, right? Already I said in last class, if angle exists in first quadrant, if angle exists in first quadrant x-axis is positive, y-axis is positive, right? In first quadrant, x and y both are positive, means argument of z is nothing but theta. Argument of z is nothing but theta, right? Theta is equal to, how we are writing? Theta is equal to, simply we are writing theta only, right? In second quadrant, if theta is an argument, then if theta is the angle, if we are finding or if we are writing argument, means we have to write pi minus theta after finding the value of theta. Next we have to write that pi minus theta. Next, in third quadrant we considered theta is moving with clockwise direction. If we consider theta is moving with clockwise direction, then angle in third quadrant, how we write? First we find theta value. After finding theta value, argument of z, how we write? Argument of z is equal to theta minus pi. Theta minus pi. Whereas in fourth quadrant, argument of z is equal to minus theta. Here we have to remember one thing. After finding the value of theta, next we have to check x and y. X and y, which quadrant exists, that line or that angle exists in which quadrant. After knowing that angle, next we have to write argument of z. Is it clear? Okay, what is our polar form? Polar form of a complex number is polar form of a complex number z. A complex number z is equal to r cos theta plus I sin theta. Okay, we derived this one, right? What is r here? R is modulus of z. How we write modulus of z? Or r is equal to square root of x square plus y square. X square plus y square. Next, for finding amplitude or for finding theta value, which form we are using here? We are using that tan theta is equal to modulus of y by x. Why we are using this modulus? We consider for derivation of this polar form, we considered angle in first quadrant. We considered first quadrant. How is our diagram? P is any point, we said, right? P be any point. P is any point. In this point, x and y both are positive. If x and y are positive, means those points exist in first quadrant. If these points exist in first quadrant, means both are positive. That's why we consider tan theta is equal to y by x. Here we have to remember one thing. What is that? Tan theta is nothing. Tan theta is not an argument. Here theta only we call argument. Argument, we say argument of z is theta only, not tan theta. Argument of z is theta, not tan theta. For finding theta value, we are using this form because you don't know tan inverse form, right? If you are writing theta is equal to tan inverse means you don't know inverse function. That's why I wrote only tan theta. Tan theta is equal to y by x. Here we have to find theta value. What is theta? Theta is nothing but argument of z. Tan theta is not an argument of z. Is it clear? Okay. Here we have to remember one important thing. What is that? Okay. 0, x, x dash, o, x, x dash. Next, y, y dash. Okay. Then, first quadrant. In first quadrant, x and y both are positive. In first quadrant, x and y both are positive. How we write argument of z? Argument of z is equal to theta only, right? Next, in second quadrant, x is negative, y is positive. X is negative, y is positive. Then argument of z is equal to pi minus theta. Is it clear? Done. In third quadrant, x dash is there. X dash means minus. Here y dash is there. Minus. X is also negative, y is also negative. Therefore, argument of z is equal to theta minus pi. Argument of z is equal to theta minus pi. In fourth quadrant, x is positive, y is negative. X is positive, y is negative. X is positive means plus minus. X is positive, y is negative. Therefore, argument of z is equal to minus theta. Argument of z is equal to minus theta. We have to remember these things. First, finding the value of theta. Next, what we have to check? We have to check if theta lies in between minus pi to plus pi or not, right? What it means, minus pi to plus pi means principal value. Principal value of theta is minus pi is less than, theta is less than or equal to plus pi. Minus pi is less than, theta is less than is equal to pi. This is called principal argument of z or principal value of theta. Is it clear? Okay. We completed first solved example, right? Today we will start exercise 5.2. Exercise 5.2. 5.2. Given question is find the modulus and the argument. Find the modulus and argument of each of the complex numbers, each of the complex numbers in exercises 1 to 1 to okay. In yesterday's class, we already solved one example, right? In this, given complex number is First one given complex number is z is equal to -1 minus I root 3. -1 minus I root 3. Okay. What is our given question? Find the modulus. Find the modulus and the argument of each of the complex numbers in exercises 1 to 2, right? Given complex number is z is equal to -1 minus I root 3. Here we have to find modulus is nothing but r, right? After that, argument. For finding argument, first what we have to find? First we have to find the value of theta. After finding the value of theta, next we have to write argument of z. Okay. Solution. Given complex number is z is equal to -1 minus I root 3. Comparing this complex number with z is equal to x plus iy. Okay, therefore here x is equal to -1, y is equal to minus root 3. Is it right? X is equal to -1, y is equal to minus root 3. How we find modulus? Modulus of a complex number, or modulus of a complex number z also be denoted as modulus of z, or also we can write r. R is equal to, what is our form? X square plus y square, which is equal to, how we write x square? What is the value of x here? X is equal to -1 whole square plus y is minus root 3 whole square. Is it right? Done. Here square root get cancels. Minus is there, power is even, right? This minus becomes plus. Here also minus, power is even, that's why this minus becomes plus, which is equal to square root of 1 plus 3, then which is equal to square root of 4, or r is equal to 2. R is equal to, or modulus of a given complex number is equal to 2. Next, what we said? Find argument. For finding the argument, here we have to find the value of theta. How we find the value of theta? By using this form. Tan theta. Here we have to remember one thing. Tan theta is not an argument for finding the value of theta. Or for after finding the value of theta, we have to write in which quadrant these 2 points exist. After knowing that, we have to write argument of z. Tan theta is not an argument of z. Then, which is equal to modulus of y by x. Then, tan theta is equal to modulus of, what is the value of y? Y is minus root 3 divided by -1. Minus or inside the minus, inside the modulus, if minus is there means it becomes plus only. Then tan theta is equal to root 3 by 1 is root 3 only, right? Tan theta is equal to root 3. We know that tan of pi by 3. Tan of pi by 3 is equal to root 3. Tan 60 degree value is root 3. Tan 30 degree value is 1 by root 3, right? Tan 30 degree is 1 by root 3. 1 pi by 3 is nothing but 60 degree. Tan 60 degree value is root 3. Therefore, tan theta is equal to tan of pi by 3. Tan get cancels. Then theta is equal to pi by 3. What is the value of theta here? Theta is equal to pi by 3. If theta value is pi by 3, next what we have to find? Argument we have to find, right? If we are finding argument means here we have to check a complex number, real axis and imaginary axis. This is our real axis value and this is our imaginary axis value. Both exist in which quadrant? Both are negative, right? Given real axis value and imaginary axis values are negative, right? Negative. Therefore, exist in these two values, or these two values or points exist in third quadrant. Therefore, the points exist in third quadrant. Okay. The point exists in third quadrant. Therefore, argument of z is equal to, therefore argument of z is equal to theta minus phi. Argument of z is equal to theta minus phi, right? Therefore argument of a given complex number is equal to, what is the value of theta? Theta is pi by 3 minus pi. Then argument of z is equal to 3 is our LCM term, right? Then pi minus 3 pi, or which is equal to minus 2 pi by 3. Therefore argument of z is equal to minus 2 pi by 3. Is it right? Argument of z is equal to minus 2 pi by 3. Modulus of a given complex number is r is equal to 2. Then argument of a complex number is minus 2 pi by 3. Is it clear? Okay. What is our given complex number? Minus 1 minus I root 3. Right? Comparing this complex number with x plus iy. Here x is equal to minus 1, y is equal to minus root 3. Here we are finding modulus of z, right? Modulus of z, how we denote mod z or r. R is equal to, what is our form? Square root of x square plus y square. Put the value of x. What is the value of x here? X is equal to minus 1. Minus 1 whole square plus minus root 3 whole square. Square root get cancels. Minus is there, power is even, right? This minus becomes plus. Here also it becomes plus. Square get cancelled, remain 3 only. Therefore 1 plus 3 is equal to 4. Therefore r is equal to 2. This is our modulus of a given complex number. Then for finding the value of theta, here we used form tan theta is equal to modulus of y by x. Here tan theta is equal to, what is y? Y value is minus root 3 divided by minus 1, right? Inside the modulus, if negative values are there, means those values also becomes positive, right? Then root 3 by 1 is nothing but root 3 only. Tan theta is equal to root 3. Then tan theta keep as it is root 3. In which angle tan value is root 3? Tan pi by 3. Pi by 3 is nothing but 60 degree. Tan 60 degree is equal to root 3. Therefore, we wrote in place of root 3 tan pi by 3. Then tan get cancelled. Theta value is theta is equal to pi by 3. Here we know the value of theta. This is not an argument. This value is theta only, right? After finding the value of theta, we have to write argument of a given complex number, right? Before writing argument of a given complex number, we have to check given points exist in which quadrant, right? Both are negative. X is also negative, y is also negative. X is also negative, y is also negative, means these 2 points exist in third quadrant, right? In third quadrant, how we are writing argument of z? Argument of z we are writing theta minus phi, right? Argument of z is theta minus phi. Already we discussed this one, right? Then argument of z is equal to, put the value of theta. What is our value of theta? Theta value is pi by 3. Pi by 3 minus pi. Therefore, which is equal to, take 3 as LCM term, then pi minus 3 pi by 3. Therefore, minus 3 pi plus 3 pi is equal to minus 2 pi by 3. Therefore, argument of z is equal to minus 2 pi by 3. What is our given question? In given question, they said only find the modulus and argument of each of the given complex number. That's why we find R and argument of Z only. Is it clear? Next question. Second question. Question number 2. Second question is minus root 3 plus I. Minus root 3 plus I. Okay. Solution. Comparing this given complex number with z is equal to x plus iy. Given z is equal to minus root 3 plus I. Therefore, here x is equal to minus root 3 and y is equal to 1. Okay, then for finding modulus or r is equal to x square plus y square, or which is equal to x value is minus root 3 whole square plus y value is 1 square. Then which is equal to square root get cancels. Then square root of minus becomes plus because power is even. Therefore 3 plus 1 is equal to 4. Therefore r is equal to 2. Okay, this is our modulus of a given complex number. Next, what we have to find? We have to find argument, right? For finding argument, first we have to find the value of theta. Tan theta is equal to y by x. Or tan theta is equal to, what is the value of y? Y is 1 divided by minus root 3. Or tan theta is equal to, inside the modulus, if negative is there means that value becomes positive only. That's why tan theta is equal to 1 by root 3. In which angle? Tan value is 1 by root 3. We know tan 30 degree. Tan 30 degree how we write? Pi by 6. Right? Then tan get cancelled. Here theta is equal to pi by 6. We know the value of theta. After finding the value of theta, next we have to check these 2 points exist in which quadrant, right? X is negative, y is positive. X is negative, y is positive. Exist in which quadrant? In second quadrant, right? In second quadrant, x is negative, y is positive. Since given complex numbers, real and imaginary exist in second quadrant. Therefore argument of z is equal to how we write in second quadrant argument of z, that is pi minus theta, which is equal to pi minus, what is the value of theta? Theta is pi by 6. Therefore argument of z is equal to, or 6 we can take here LCM, then it becomes 6 pi minus 5, right? Therefore argument of z is equal to 6 pi minus pi is 5 pi by 6. Like this we have to find. Is it clear? First we find r, comparing given complex number with x plus iy. We are comparing this complex number with z is equal to x plus iy. Therefore, x is equal to minus root 3, y is equal to 1. Then r is equal to, this is our form for finding modulus, right? Then what is the value of r? R is 2. For finding the value of theta, tan theta is equal to modulus of y by x. Put the value of x and y. Then tan theta is equal to 1 by root 3. In which angle tan value is 1 by root 3? Tan 30 degree, right? 30 degree we can write in radian form pi by 6. Here tan get cancelled. Remain theta is equal to pi by 6. After finding theta value, for writing argument of z, what we have to check? We have to check these 2 points exist in which quadrant, right? These 2 points exist in second quadrant. In second quadrant, how we write argument of z? Argument of z is equal to pi minus theta. Then like this we can say, right? Argument of z is equal to 5 pi by 6. Is it clear? Okay. We will go for next. Second question. Convert each of the complex numbers each of the complex numbers given in exercises 3 to 8 in the polar form. Already we know polar form, right? What is our polar form? Polar form of a given complex number z is equal to r cos theta plus I sin theta is our polar form, right? So writing polar form, what we have to find? We have to find the value of theta and modulus. Modulus is nothing but r, right? So after finding the value of theta, what we have to check? We have to write argument of z, right? In this third one, 1 minus I. Solution. Given complex number z is equal to 1 minus I. Comparing this with z is equal to x plus iy. Then what is the value of x? X is equal to 1, y is equal to minus 1. Okay, done. For finding modulus of z or r is equal to square root of x square plus y square. Then which is equal to square root of x square is 1 square plus minus 1 whole square, which is equal to square root of 1 square is nothing but 1 only. Then plus minus 1 whole square. Minus is there, power is 2. That's why this becomes plus. Therefore, r is equal to root 2. Modulus of a given complex number is root 2. Next, what we have to find? Theta value, right? Tan theta is equal to modulus of y by x. Then tan theta is equal to modulus of, what is the value of y here? Y is equal to minus 1. Minus 1 divided by plus 1. That tan theta is equal to, inside the modulus, minus becomes plus only, right? Therefore, denominator is also 1. Here remain only 1. Then tan theta is equal to, in which angle tan value is 1? We know tan 45 degree is equal to 1, right? Therefore, tan 45 degree in radian form how we write? Pi by 4. Because tan pi by 4 is equal to 1. We are replacing 1 is equal to tan pi by 4. Usually we will write tan pi by 4 is equal to 1. Here we are replacing 1 is equal to tan pi by 4. Because we need theta, right? We have to cancel this tan. If we want to cancel this term means tan means here we need tan, right? That is why tan pi by 4 is equal to 1. Left side, right side, tan get cancels. Then here it remains theta is equal to pi by 4. Here the value of theta is pi by 4. Already we said theta must be principal value. What is the principal value? Theta lies in between minus pi to plus pi, right? So for finding the argument of z, we have to check the given point is there in which quadrant, right? X is positive, y is negative. X is positive, y is negative. Means which quadrant it is? Fourth quadrant. Given points exist in fourth quadrant. Since since a given complex number real and imaginary, real and imaginary exist in fourth quadrant. Therefore, argument of z. Argument of z is equal to, in fourth quadrant, how we write argument of z? Argument of z is equal to minus theta, or argument of z is equal to, what is the value of theta? Theta is equal to pi by 4. Therefore, argument of z is equal to minus pi by 4. Right? This is our argument of z. What they said here? Convert each of the complex number given in the exercises 3 to 8 in the polar form. Right. What is our polar form? Polar form of a complex number. Cm is nothing but a complex number. Is complex number z. Z is equal to r cos theta plus I sin theta, right? Which is equal to, what is the value of r? R is equal to root 2 into cos. What is theta? Argument of z is nothing but theta, right? That is minus pi by 4. This theta should be principal value. Principal value means we have to find argument of z, right? Then plus I sin pi minus pi by 4. Okay. This is the polar form of a given complex number. This is a polar form of a complex number. This is a polar form of a complex number. What is our given complex number? Given complex number is 1 minus I. This is the polar form of a given complex number 1 minus I. Is it clear? Okay. Already we know how to find r and how to find the value of theta. After finding the value of theta, remember one thing, we have to write argument of z. Argument of z means theta must be principal value, right? That's why argument of z is equal to minus pi by 4. Why we wrote this minus? Because this point x is positive and y value is negative. X is positive, y is negative means this exists in fourth quadrant. In fourth quadrant, argument of z have we are writing minus theta. Therefore, argument of z is equal to minus pi by 4. Next, we have to write polar form of complex number, right? Polar form of a complex number z is equal to, this is our form, right? Here we know the value of r. R is root 2. Then theta, principal value of theta is minus pi by 4 plus I sine minus pi by 4. This is the polar form of 1 minus I. 1 minus I is Cartesian form and this is our polar form. Is it clear? Okay. Next one. Okay. Next. Next question is, fourth question, minus 1 plus I. Right. Given complex number is minus 1 plus I. Right. We have to write this complex number in the form of polar form. We have to write this Cartesian form to polar form. We have to convert this Cartesian form to polar form, right? How we write a given complex number? Given complex number, we will write z is equal to minus 1 plus I, right? Then comparing with given complex number with z is equal to x plus I, right? Therefore, here what is our x? X is equal to minus 1. Then what is y? Y is equal to plus 1. Here nothing means I into 1 is there, right? That's why y is equal to 1. Then r is equal to x square plus y square, then which is equal to, what is the value of x? X is minus 1 whole square plus y square is 1 square, then which is equal to square root of minus 1 whole square is nothing but 1 only, minus becomes plus because power is even, 1 plus 1, therefore r is equal to root 2 or modulus of z is equal to root 2. Modulus of z is root 2. Next, what we have to find? We have to find tan theta. Theta value, right? For finding theta, what we are using? Tan theta is equal to y by x. Then tan theta is equal to y value. Y is equal to 1. Then what is the value of x? X is minus 1. Okay. Then tan theta is equal to, numerator is also 1, denominator is also 1, right? If modulus is there means minus becomes plus. Therefore, here it remains only 1. Tan theta is equal to, in which angle? Tan value is 1. We know tan 45 degree. How we write 45 degree radian form? Pi by 4 is nothing but 45 degree, right? Tan 45 degree is equal to 1. Or tan pi by 4 is equal to 1. Tan get cancels. Then theta is equal to pi by 4. Okay. Then for finding argument of z, we have to check given complex number exists in which quadrant, right? X is negative, y is positive. X is negative, y is positive means the given complex number exists in second quadrant, right? Given complex number exists in given complex number, real axis and since real and imaginary axis exist in second quadrant. Second quadrant. Second quadrant. Therefore, in second quadrant, argument of z is equal to. Therefore, argument, or also we can say amplitude of z is equal to. Amplitude of z is equal to, in second quadrant, pi minus theta, or which is equal to pi minus, what is the value of theta? Theta is equal to pi by 4. Then which is equal to 4 is LCM, then 4 pi minus pi. Then argument of z is equal to 3 pi by 4. Therefore, polar form of z is equal to r cos theta plus I sin theta, right? Therefore, polar form of a given complex number is -1 plus I is equal to, what is R? R is √2. Then cos theta is 3 pi by 4 plus I sin theta is 3 pi by 4. Okay. Polar form of this complex number is √2 cos 3 pi by 4 plus I sin 3 pi by 4. Is it clear? Okay. Given complex number is -1 plus I is there, right? Z is equal to, this is our given complex number. X is equal to -1, Y is equal to +1, right? If X is negative, Y is positive, means this complex number exists in second quadrant. Here we have to find modulus, right? For finding modulus of Z, we have to find R. R is equal to, this is our form. Next, we know the value of X and Y. Put the value of X and Y. Okay, therefore R is equal to √2. For finding the value of theta, what we have to write? Which form we have to use? Tan theta is equal to modulus of y by x, right? Y is 1, x is -1. Then tan theta is equal to 1. In which angle tan value is 1? Tan 45 degree is 1, right? Therefore theta is equal to pi by 4. Real and imaginary axis exists in second quadrant. Therefore, argument of z is equal to pi minus theta. Pi minus theta is pi by 4. 4 is LCM, then argument of z is 3 pi by 4. Polar form of complex number r cos theta plus I sin theta. This is our Cartesian form. This is our given complex number. This Cartesian form we are writing in polar form, right? For writing polar form, we have to find modulus sign argument. This is the polar form of a given complex number. Is it clear? If you have any doubt, chat box is on. You can ask in chat box, right? We will continue in next class. Thank you.
They are asking question number 3. The question exercise 5.2. It is 1 minus I. Here, z equals to 1 minus I. If you compare with z equals to x plus iy, x equals to 1. This we can write 1 plus minus 1 into I. Y value will be minus 1. Real part, imaginary part. We require polar form. We have to convert this in the form of polar form. Formula z equals to r into cos theta plus I sin theta. Therefore, r equals to root over x square plus y square. We will get 1 minus 1 whole square 1. We are getting root 2 as r. When it comes to the amplitude of theta to find out, first we will convert. We are having the formula derived tan theta equals to modulus of y divided by x. Whatever the angle we are having, it is plus minus. Actually, we are having plus minus. It is second quadrant. Second quadrant means argument pi minus theta. But first of all, we will find out theta. First of all, we will convert in the form of theta. Therefore, tan theta equals to modulus of y divided by x. Whatever we will convert in the form of 0 to 90 first. It is minus plus. We are having it is in the fourth quadrant. Plus minus. We have to take minus theta. It is conjugated. Okay, ma? In plus means theta. Minus means minus of pi minus theta. This table we have to remember there, or how it is can we have discussed it there. Tan theta equals to modulus of y by x. Therefore, tan theta equals to modulus of y value minus 1 by 1. We are getting 1. Therefore, theta here we convert in the form of 0 to 90 degrees first quadrant. We are getting theta as pi by 4 as tan theta equals to 1. Now, if you come to the argument of z, it lies in argument of z lies in fourth quadrant. You see the signs there, plus minus. It lies in the fourth quadrant. Rotation you have to see afterwards. First of all, we are converting every angle in the first quadrant. Afterwards, argument of that is Archana plane rotated to the fourth quadrant. Plus minus. Therefore, plus minus means we are having minus theta. Theta how much we are getting? Pi by 4. Therefore, minus pi by 4. This argument of z we are getting as minus pi by 4. Or otherwise, simply it is here theta we are taking. This is conjugate. It is theta here minus theta we can take. That is why we are getting minus theta. Therefore, argument of z we are having minus pi by 4 and r we are having root 2. Now, polar form z equals to r of cos theta plus I sin theta. Therefore, z equals to root 2 into cos of pi by 4 plus minus pi by 4 I sin of minus pi by. You can check here there. If you want, you can check the answer also. Cos of minus theta we are getting cos theta. Cos of pi by 4. Sin of minus x minus I sin pi by 4. This is the required answer. Both either this or this, both are correct. in polar form, we are using tan theta equals to y divided by x modulus converting into the first quadrant. If you see the diagram, this is r, this is theta. Distance we are taking r, angle we are taking theta. With this OAB, from triangle OAB, we have been proved x equals to this is x, this is y. Therefore, we are getting here, we have seen sin theta equals to y by r, cos theta equals to x by r. Therefore, x equals to r cos theta, y equals to r sin theta. We are taking tan theta equals to opposite side by adjacent side in the first quadrant, as the principal value lies between pi and minus pi. Principal amplitude minus pi less than theta less than or equals to pi. Therefore, minus pi to pi we are taking. We have to move from the first quadrant to the second quadrant up to negative minus pi. Therefore, we have to use tan theta only. We should not use the cot there. Cot or sin or cos there. We can use x equal to r cos this. You can use r sin theta. You can use. But in general, we will take it as defined as tan theta equals to modulus of y by x, as it lies in between minus pi to pi. If you move here, if it is theta, it is 0. Here it is pi by 2, 0 to pi by 2. Second quadrant, if it is moves, it is here pi by 2, here pi. It is moving pi by 2 to pi. And if you take third quadrant will take it as, if you take here, this theta, you take here minus pi, here it will be minus pi by 2, y dash. Therefore, minus pi to minus pi by 2. And next fourth quadrant, if you take like this, here it is moving minus pi by 2 to 0. If principal amplitude, if you see rotation, we are taking from minus pi to minus pi. Therefore, we define as tan theta. We will not define rotation from anti-clockwise. You have to take it. We should not take the clockwise direction. Depends on the principal amplitude minus pi to pi. We have to take tan theta only.
Yes, many of the students are asking regarding the find the amplitude. Why you have to take only tan theta? Why you can't take other trigonometric functions? Okay, so actually, what is the polar form of the complex number? You know that if you have x plus iy is one complex number, okay, then if you express this one into polar form as r into cos theta plus I sin theta, where r is called modulus and theta is the amplitude. What is the modulus? Modulus is the distance of a point P with origin. Theta is the angle made by this line with the x-axis. Okay, it is theta and it is r. So if you have x plus I, either you write in the form of Cartesian form or polar form. Okay, so why you have to take only tan theta? Okay, if you express this Cartesian form into polar form, we have to find the value of r and theta. That is very important. Okay, you have to express the given complex number Cartesian form into polar form, sir. You have to find the values of r and theta. R is the distance of a complex number from origin, and theta is the angle made by that complex number. Okay, suppose if you like separate real and imaginary terms, okay, r cos theta plus I r sin theta. Okay, so equating the real part and imaginary part. Okay, r cos theta equal to what? X equal to r cos theta. Okay, so what is the imaginary term here? R sin theta. Here what is that? Y equal to r sin theta. Okay, so squaring and adding it, you will get a modulus. Modulus already know that. Okay, modulus equal to root of x square plus y square. Okay, then see, we have to find the amplitude or argument of complex number that gives the angle made by the complex number with x-axis. Why you have to find only tan theta? Here you have to find the tan theta value. Instead of tan theta also you can take already yesterday I taught. Okay, in different cases, sir, by taking only sin theta and cos theta also, you can find the value of theta. Theta gives what? Amplitude. Amplitude is nothing but angle made by the complex number with x-axis. Okay. See here, main intention is what? To find the value of theta. This is one equation, this is another equation. To find the value of theta, you have to solve this one. Either you have to substitute equation 1 in 2 or 2 in 1 or dividing 1 by 2 or 2 by 1. If you divide these equation, this you have to take 1 and 2. Okay, 2 by 1. Y bar x equal to r sin theta. Main intention is what? To separate theta. You have to find the value of theta. Okay, r sin theta by r cos theta. See, this r get cancelled. Y by x equal to tan theta. Okay, so this gives the tan theta value, but you have to find the value of theta. That is why you have to take the theta equal to tan inverse of y by x. Okay, this gives the amplitude. Then some of the students they are asking why you take pi minus theta minus of pi minus theta. Why you are taking different cases? Okay, actually main intention is what? To find the value of theta. Theta is nothing but what? Amplitude. See, if theta is like maybe 0 to 90 degree or 90 to 180 degree or 180 to 270 degree or 270 to 360 again 360 plus 30. It means what? You can find infinite values of theta. Okay, it may be if suppose here 330 means again 390 also get same values. Therefore, we have a infinite values of theta will come. Therefore, you have to restrict some angle like that. You should get only one answer. So that is why you have to find the value of theta. So amplitude you have to restrict from minus pi by 2 to plus pi by 2. That is called a principal value of the complex number. Either you have to call it the principal value of the complex number argument. Don't call a principal argument. Okay, either you have to call principal value of the complex number or argument of the complex number. Amplitude is nothing but what? Total angle. It may be theta is here or here or here or here. Okay, we have infinite values will come. If you're rotating again once again, we have infinite values will come. All gives what? Amplitude. So if you are considering the smallest value of theta, that is called argument. So what is the smallest value of tan theta? Because we are considered as a tan theta. Okay. So we have an answer in terms of tan theta. What is the smallest value of tan theta? So in which quadrant it is positive and in which quadrant it is negative. See here, tan theta is positive here and positive here. Smallest value is what? Here, 0 to 90 degree. So in which quadrant it is negative? Either it will be second quadrant or here. It means it is pi by 2 plus theta. It is minus pi by 2. Okay, that is why theta should be lies between minus pi by 2 to plus pi by 2. Gives the argument of the complex number. Okay, we have infinite values of theta will come, that all are called amplitudes. If you take smallest value, okay, so lies between minus pi by 2 to plus pi by 2, that amplitude is called as argument of complex number or principal value of the complex number. Okay, is it clear? And One more doubt is what? Modulus, okay, that I told. So if you are taking tan inverse of y by x, you have a different values of theta will come. Then that is the one method to restrict from minus pi by 2 to plus pi by 2. By considering modulus of, first we have to find the value of theta. So if y is negative, x is positive, x is negative, y is positive, in different cases are there. To find the argument of the complex number, because if you want to write into polar form, theta should be argument of z. Argument of z means theta should be lies between minus pi by 2 to plus pi by 2. You should get that one. That is why you have to take modulus means by considering first a positive sign, by considering both are positive sign, you have to find the value of theta. After that, you have to take either it will be in the first quadrant or second quadrant or third quadrant, fourth quadrant will come. Different cases are there. Now, according to that cases, you have to restrict the theta from minus pi by 2 to plus pi by 2. Why you take modulus means first by considering the positive value, find the value of theta. Okay, after finding the value of theta, it may be in third quadrant or fourth quadrant, you have different values will come because theta is positive in two quadrant. Okay, you should restrict in the first quadrant, so that you have to use the case, different case, x is positive, y is negative, you know that one. Okay, that value you have to take restrictor. So theta from minus pi by 2 to plus pi by 2, find the value of alpha. First you have to take mod. Mod means what? Positive value you have to take first. After that y is negative, x is positive, both are negative. You should get the amplitude in terms of argument. Argument means what? Minus pi by 2 to plus pi by 2. Okay. Cot also you can take, no problem. Because this here, all are taking that. Cot also you can take, no problem. Again, we have different cases to discuss. Okay. So here, some formulas are there, you can use anywhere. Okay. That is why you have to take tan is very easy to find and also you can find. Suppose if you take cot also, again its principal value is different. Okay, so that is why again we have different answers will come in terms of tan. Cot also you can take, but in the textbook they are given tan theta means all. If you go, so America also will get same amplitude or argument. Okay, so that is why you have to take tan. Cot also you can take. Why can't take only sin theta? Because only by taking sin theta you will not get it. Okay, so that is why you take it. You can take tan theta or cot theta also will get that. But the principal value of the cot theta is again different. Again, we have different cases you have to discuss. That is why you have to remember only one form, tan theta. Okay.
ಇಲ್ಲಾಂದ್ರೆ ಇನ್ನೊಂದ್ಸರಿ ಟ್ಯಾನ್ ರೈಸ್ ಮೈನಸ್ 5 ಬೈ